Hello, welcome back to Math with Patrick. It's June 4th, and we're solving problem number 155 from the Daily Epsilon calendar. We need to show why this trig expression is equal to 4 today. So what this says is cosecant of 15 degrees divided by cosine of 15 degrees is supposed to be equal to 4, though I don't really see it just yet. The first thing that I want to do here is get rid of this cosecant. We can use a reciprocal trig identity. Essentially, cosecant of some angle is going to be 1 over sine of the same angle. You could also rewrite it differently. You could maybe swap the positions of these functions, like sine of some angle is equal to 1 over cosecant of that angle. But at least the first one that I wrote is going to be the one that I want to use today. Basically, this just shows me that I can shove cosecant into the denominator and also just call it sine. And this isn't going to be like changing the value of my fraction. It just kind of changes what it looks like. So I'll do sine of 15 degrees in the bottom times cosine of 15 degrees in the bottom. And I know whenever you see sine and cosine together, multiplied, we can use some trig identity. I believe it's a double angle identity for sine. And how about let's hop on over to Desmos real quick, just so we can like visually prove what the identity is. So we're working with sine x times cosine x, essentially. And as you can see, it basically just looks like another sine wave. Though its amplitude is a lot shorter, like it's more scrunched vertically, and its frequency is a lot greater because the waves happen more frequently than the original sine wave. And to kind of compensate for those things, we could do some graph transformations on the original sine graph to try to match the purple one. So if we multiply something on the inside of the argument of the sine function, some positive number, we're going to scrunch the graph up a little bit like that. And so larger numbers scrunch it more. Smaller numbers, like numbers closer to 0, will kind of widen it out. And then negative numbers just happen to flip it. But I want to scrunch it a little bit, and I'm trying to match these x-intercepts with each other. And essentially the right number here is going to be 2. Maybe you could have seen that already because this purple wave kind of completes 1 and then 2 cycles within the same time that the black wave completes 1 cycle. And so this 2 helps me scrunch it up just the right amount. And then we can see here that the maximum of the purple curve is 1/2. And so I can multiply something out front like this to change the amplitude of my black sine wave here. Larger numbers stretched out more vertically, numbers closer to 0 smush it down, and so 1/2 is going to be the appropriate value here to match what we got going on with this sine times cosine. So when we return back to the whiteboard page, I'm just going to replace sine of 15 degrees times cosine of 15 degrees with this expression here, where this x is also going to be that same 15 degrees. So let's pop that identity in here. Essentially, this sine 15 times cosine 15 will be the same as 1/2 times sine of, and then 2 times 15 degrees. And how about let's just deal with that 1/2 first. Right here, 1 divided by 1/2 is 2. Or maybe if you think about having fractions in the denominator, you can kind of get rid of them by flipping it. Only if there's multiplication here. Like regardless, there's a lot of ways to think about it. Essentially, I would just rather say 2 over sine, and then I'll do 30 degrees because I can multiply these together. So ultimately, this is a slightly simpler way to rewrite the same thing. I just combined these to a 30, and then I dealt with this times 1/2 in the denominator. Now we just need to show what sine of 30 degrees is. Maybe you could think about your unit circle, and this 30-degree angle here brings us exactly halfway up between 0 and 1. Maybe you can think of your 30, 60, 90 triangles, where these 30, 60, 90 triangles have a certain uh, relationship with the side lengths. Like if this is a 1, that's a 1/2, and this is a √3/2. This essentially comes from studying like an equilateral triangle, cutting it in half, doing some Pythagorean theorem stuff on it, and then this 1/2 is going to be that value of sine of 30 degrees. However you want to think about it, sine of 30 is just 1/2. You could even plug it into a calculator. And so ultimately we're going to get 2 over 1/2. And look, there's another 1/2 in the denominator. And I'm going to do the same thing. I'm just going to flip it up there to the numerator and call this 2 times 2. And that's 4. So the answer is 4 today. And we just needed to use this double angle identity here, where we doubled the angle to solve for 4 and get 4 to match today's date. So that's all from me today, and I'll see you in the next video tomorrow. Bye.